before. You've seen this graph? No. We did this actually 2 days ago. Talked about it a little bit yesterday and did the calculations for each section yesterday. Let's talk about how you would do these calculations. Take a look. All right. If we're at the melting point or the boiling point, it's a very simple calculation. You basically just have to know what the heat of fusion is or the heat of vaporization is and multiply it by how many grams you have. Okay? So it's the heat of fusion times the mass or the heat of vaporization times the mass. That's all you had to do. It's a simple conversion. Okay? Same graph we saw yesterday. We also learned how to do these guys here, where you're just changing the temperature of a solid, a liquid, or a vapor. What equation do we use there? Remember what it was called? Remember what it actually said for the equation? Delta H equals MC delta T. Remember? So you'd have to use that here. Here's why. And by the way, how will you know which one you're using? Well, there's obviously a temperature change here. You have to be. Is there a temperature change here? No. So you're using that here, you're using that here, and you're using that there. Right? That makes sense. Okay. Now, here's what I'm going to ask you to do now. You did separate ones of these and separate ones of these, and now I'm going to ask you to put it all together. If I asked you, well, how much energy does it take to go from ice at maybe minus 10 degrees to steam at maybe 120 degrees? You can now answer that question. But how many calculations will it take to do it? Not 2. Not 4.
1.
No counting.
7.5.
None.
Not none.
1.
Not 1.
3.
Not 3.
5.
5. I finally heard it. Yeah, I'm glad you all understand this because that's good. That's clear that you understand this.
I got it now.
Take a look. Here's what you'll have to do. I'm going to just outline it for you, then we're going to do one. But I'm not going to do one that has all 5 because that takes a very long time. You may get one that has 3 or 4 or even 2 on the homework tonight, and on what I'm going to do on the board is going to have 3, I think. But take a look. All right. You watch it? Shh. Here's what you'll have to do. First, you'll have to go from minus 10, right here, up to here. That's going to be one calculation using this guy. Got it? Then, you'll have to figure out, well, how much energy would it take to melt all those crystals? That's the second calculation. We'll call that guy. We'll call this A. We'll call this B. Then, going from 0 up to 100 is going to be part C, where you'll use that formula. And then you got to figure out how much it takes to melt or to vaporize them. That's going to be D, this was C, and then E, your final part, will be up there, going from, say, 100 to 120. Now, each one of those is a different calculation, and you have to sum them all up at the end. Okay? All right, now, let's talk about that by doing. I don't have any notes to give you here. Just going to do one like that. Okay? Check that out.
Why do you have 3 there?
I believe that's where it is in your notes. I could be wrong.
Oh, is it? I have no idea.
Well, then why would you ask that?
I didn't think there was.
I had no idea, but I'm going to question why there's a 3 there. That makes complete sense.
No, never mind. I'm done with you.
Forget the snowball.
Yeah, I know. Skip snowball. I'll save you money.
Mm-hmm. Wait, the girls pay too? I thought they just ask.
We ask, we buy tickets.
Really?
We ask, we buy tickets, we get the dress.
Really?
Yeah.
I didn't know that.
You know what you do? Buy
This
dinner.
is a deal. Why did they have this when I was in school?
Yeah, but you're gonna save on dinner. Because guess what? I'm not cheap.
Mm-hmm.
I just told him he was gonna save.
All right.
No, because we're not going anymore.
Mm-hmm. Now, if you look at this guy, what I want you to do for him, and for anyone like this, is I want you to draw yourself a graph. I can get rid of those hiccups right now. Karen, look at me. Take that in your hand, take the water right now. Open it up quickly. Take a deep breath. Quickly. Take a deep breath. Wait. Drink, and continue drinking. Continue drinking. Just do it. Just do it. You will not have another hiccup. You've had it for the last 5 minutes.
No, or put paper towels over it.
Shh. Just do it. Just drink. Come on. They're already gone, by the way.
Don't stare at me.
That's why. See, there's 2 ways to get rid of them. That's one of them. The other one is to scare people. She's scared. She no longer has the hiccups. Those are the 2 ways.
Oh.
Yeah, that's true. All right, so she's gone. They're gone. All right, now, you ready? That was, by the way, for all you people at home, a cure for hiccups. 2 cures for hiccups. Scare the crap out of them. Or, yeah, and plus it was being annoying, so that's why I had to get rid of them. All right, take a look. All right, let's take a look at this guy and what's happening. I want you, for any of these problems, and this goes for the test as well as the homework, All right, I need you to draw a phase change graph like we just saw. Now, I know what some people will do because of that. Because I said that, here's what they'll do. Okay, phase change graph, here you go. Oh, I want a green one here. And they'll say, okay, I drew my phase change graph. But that's not what happened in this problem. Take a look at the problem again. It went from ice at -12 to liquid water at 49. What will the graph look like? I need you to draw a graph. Don't make it huge because you're going to be doing a lot of calculations underneath it. But I need you to draw a graph that looks like this. Watching? First of all, we have to know what's in our axes. What's our y-axis if we're doing a phase change graph?
Degrees.
Temperature. Degrees are the units. Temperature is the thing you're measuring. It's the quantity you're measuring. What is my x-axis? Heat or time. All right. In the case of our lab, it's going to be time because it's going to be sitting in hot water for a longer period of time. Okay, so heat or time. All right. Now, in the we're going to do that lab second half of this period. What's my starting point? Read the question. What is it?
-12.
Everybody agree it's -12. There it is, right there. Okay, so I put -12 right here. I'm going to set him in heat. I'm going to put him in hot water in the case of our lab. You're going to watch those crystal temperatures go up and up and up until what? The melting point. What's the melting point of water?
0.
0. So at 0, and I have to label 0 here, it will level off. Once all of those crystals melt, what will it do then? It will not boil. It will not go directly from melting to boiling. It will heat up again. But where do I stop this guy? Let's take a look again. 49. So it's going to go up and up and up and up and up until it gets to 49 degrees. Okay? So that is your graph. That's your phase change graph, and I need you to label each of those parts to it, A, B, and C. Now I'm going to use different colors. I'm going to use different colors for my, actually, I'm not going to use different colors here because it won't show up in the white. But A, B, and C are the 3 parts. 3 different calculations you have to do. Okay? And we're going to have to do those 3 calculations underneath your graph. So you have your graph drawn, and if you wrote it that small, you could even do it to the side. But either underneath or to the side, whatever you did, we're going to do the calculation for A, B, and C in this problem. And then what will we have to do with those 3 calculations? Add them up. Okay, so let's do that. Ready? Let's do part A first. What's happening in part A? Let's take a look again. If you don't remember, that's why you drew the graph. What's happening in part A? Solid ice is going from -12 up to 0. So what equation are we going to use here? Delta H equals MC delta T. Can't you see the fusion? He's not melting. All right, so here we go. Delta H, well, first of all, delta H equals, M equals, C equals, and delta T equals. Got it? Obviously, delta H is your unknown. Your mass, what was your mass from the problem? Look up above. 14.5 grams. Now, I got to be careful about the specific heat. See, which specific heat for water am I using? 2.09 joules per gram degree Celsius, because that's the specific heat of what? Solid water. Solid. You got to look above. There's 3 of them. There's water as a solid, as a liquid, and as a vapor. And delta T is, remember, TF minus TI. You got to be careful of that too. What's my final temperature of this problem?
For that, yeah.
What's my final temperature for this problem?
0.
I knew it. I knew it. It's exactly what I expected. I got 49. I'm getting people who are subtracting the 2. Let's go back to the chart. There's a reason you made that graph. We are doing only part A. It went from -12 to 0.
Wow.
That's a huge mistake, and people make it all the time. Okay? So it's your final temperature is 0 in this part, and your initial temperature was -12. So it's minus a negative 12.0. So basically, you're getting a positive 12.0 degrees Celsius. See that? Again, if you don't, let's look at it again. Watch. We're doing this in pieces. We're doing part A of where you're just heating up the solid ice from minus 12 to 0. That's why your temperature change is just going to be 12 degrees. The next part, we're going to do the melting. We'll use the heat of fusion then. And the third part will go from 0 to 49, and that's what our temperature change will be. Okay? All right. Let's do the equation now. Delta H equals mc delta T, which equals 14.5 grams times the specific heat of 2.09 joules per gram degrees Celsius times the delta T, which is 12 degrees Celsius, 12.0 degrees Celsius. Get your calculators out, do the math for that, see what you get.
This is gonna take forever to do on this problem.
Right, that's why you're only going to you're only going to get one of these on the test.
Oh, yeah. Wow, you're a good teacher.
We're back on now?
No.
Yeah.
Oh, okay.
Oh, darn.
All right. What do you get for that? What's your delta H for this guy? What'd you guys get? 364? Is that what you said? I heard 364 joules. Because remember, grams cancel, degrees Celsius cancel, 364 joules. That's answer to part A. 364, is that right?
Yeah.
Okay. All right. So there's part A.
Part B.
What are we doing for part B? Part B is the easiest one. All we're doing is melting ice. Let's use a different color here. Let's use yellow. All right, so for part B, all right, I have to fit all this on the board so you can see it from the, on the screen. But you guys obviously have enough room. You can put this anywhere you can fit it. Basically, all I'm doing in part B is figuring out that 14.5 grams of ice is melting. So it's 14.5 grams times the heat of fusion of ice. And that's the heat of fusion of ice is what? Has to be given to you. You don't have to memorize it. What is it? 3 what? 334 joules per gram. Correct? Grams will cancel and leave you with what?
Go.
So, do the math for that. 4840. Is that right? 4840 joules. Put a big box around that guy. So there's two of our answers. We have A is, this guy was A, was 364. B is 4. By the way, notice something about the difference between this. This is pretty impressive. The amount of heat it takes to melt, or to simply change the temperature of the ice isn't that great. But look at how much more energy it takes to melt the ice, because you've got to break down the crystalline structure. And you know what? If we've been doing if we want to vaporize water, it's even worse, because the heat of vaporization for water is 2,000 or something like that, right? Versus 334 joules per gram. So it's it takes a lot of energy to boil water. It takes a lot of energy to melt ice. All right, and that's why we use water. I told you the other day as a coolant. All right, the last one is C, and the last color I have that actually shows up on a blackboard is this one. So we'll call this C.
I like that color.
It's not a bad color. It's kind of, if it was really orange, I like it, but it's kind of more of a brown.
I like it's like a pale orange.
Pale orange, yeah. Pale rider.
Orange.
Orange.
That's cute.
All right. Let's see what's happening in this section. Part C is going from here to there, from 0 to 49. Liquid water. Let's take a look at what we got to do for that one. It's going to be another MC delta T one. So we have delta H equals, M equals, C equals, and delta T equals. My delta H is obviously my unknown. What's my mass?
14.
Notice the 14.5 grams shows up in every problem. You have to know how many grams you have of this stuff, no matter what. The specific heat now is not 2.09. It's not 2.03. It's 4.184 joules per gram degrees Celsius. And what's my delta T?
49 degrees.
TF minus TI. So it is 49 is where you ended up. And you started this time not at minus 12, but at 0. So it's basically 49 degrees. So delta H equals MC delta T. Fitting all this on the board is no fun, but It fits. Delta H therefore equals 14.5 grams times 4.184 joules per gram degrees Celsius times 49.0 degrees Celsius. So part C equals how much energy?
2970.
2970. Everybody get that? Double check, make sure. Looks good.
Are we gonna ever have to find like the mass instead of the delta
It's possible I could ask you for that. It's not that hard. As a matter of fact, in the lab we do on next week on Tuesday for you guys, or Monday, I forget which day. We will be doing something a little bit different than this. We'll be kind of messing around with the heat of fusion equation. But I think as far as the test is concerned, no. As far as the test is concerned, the only way you would see that would be in a bonus situation where I ask you to change to solve for something other than the graph itself, temperature or heat energy. Okay, we still are not done. We now have to get the total by adding up A plus B plus C, right? So I have to add up 364, 4840, and 2970. Add all those up and tell me what you get. Anything else? What is it?
170.
8,170
Yeah.
for? Well, for significant figures, what's the rule for adding and subtracting? These are decimal places. But to be honest, the correct answers for these, all right, this zero was not significant. It was just a placeholder, so the number of decimal places, that one didn't count. Should we have rounded off? Should we round off to this at this point? Because neither of these are these zeros significant. You see what I'm saying? So technically, he's right. It should be just 7B. But I'm not going to take off for something as arcane as that. All right. Good enough?
That's our final answer.
That is. Now, before, I almost forgot. This is what I want to do. The reason I want to use this video instead of the other one. What I did this off camera, but I wanted to do it now because I realized the kind of mistakes I was getting when they started on the homework. But you're going to have about, what, 20 minutes to work on the homework? Watch this. That graph we just did. This one here, that's pretty basic. Not a hard one to understand. Matter of fact, it's very similar to what you're going to see in the lab in about 20 minutes. However, in the homework and on the test, it's very possible that you can get a graph that will look a lot different than that. Take a look at this. Okay? What if I told you I was going from, I want you to look at these different scenarios, and we're going to draw a graph for each of them. What if I were going from water at 120 degrees to 0 degrees? Okay? And I froze it, and then froze it at that point. What would that's what I'm not writing all the words down, but the homework will ask you a question to draw a graph like that. The graph is starting at 120, and it's ending at 0, right? Okay. So what happens? It goes from 120 down to what? A 100. Then it flattens out while all of that's condensing, and then it goes down to 0. And it could have just stopped like that, and that could have been the other thing. But if it also said you froze all that at 0 degrees, you'd have another line right there. So you'd have 1, 2, 3, 4 calculations. Okay? I could have said, let's start with water at 40 degrees Celsius, and I'm going to get it to 110 degrees. Well, again, I have a draw. This one will look like this. Y'all agree? It will look like that. What if I started with ice at 0, and then I melt it and vaporize it to, let's just say, 115? That graph is going to look like this, and I hope y'all get this. Ice at 0, here's 0, and melt it up to boiling, boil it up to 115. So your graph would look like that. 1, 2, 3, 4 steps. Okay, so you have a lot of different possibilities here. Sometimes you may only have 2. All right. On the test, it could be any of those. I probably won't give you all 5 because it will take so long. All right. But you're going to get at least 2 or 3 steps combined. All right. And each of these for the homework, make sure you grab.